Okay, hello dear all. I hope you are doing well. So we are starting the second part of section 3, alkenes and alkynes. We talked about alkenes in the first video. Now we are going to talk about alkynes, okay? Identify and name the alkynes and draw their structure from the name. So both are kind of the same if you understand the rules for naming, okay? And I recommend you to go through if lesson 66, especially video, because it's nicely described in terms of the naming system of alkynes. Okay, we already know saturated hydrocarbons, the unsaturated ones, and now we will talk about alkynes. So what's an alkyne? Alkynes are unsaturated hydrocarbons that contain at least one triple bond. So everything here is the same as we covered in alkenes, okay? Everything in terms of naming, it's all the same thing, okay, in the previous one. The only difference now is instead of saying alkene, we will say alkyne, right? So the simplest and the mostly used alkyne is ethyne, which is C2H2, which is widely known by the name acetylene. Okay, acetylene. Sorry, acetylene. So this ethyne is made of two carbons, and between the carbons there is a triple bond. Okay, and here you can see it. So carbon-carbon triple bond, each one has an H. This is ethyne, or commonly known as acetylene, okay, or acetylene. How do we name alkynes? So alkynes, straight chain and branch chain alkynes are named the same way we name alkenes. نفس ما تعلمنا في الفيديو اللي فات في الالkenes. The only difference is that instead of saying ene, we will use the last suffix of yne, because yne comes from alkynes here, yne, right? The formula of an alkyne is CnH2n-2. So if you have C3, okay, this is going to be H, okay, 2 times 3 minus 2. What is 2 times 3? It's 6. 6 minus 2 is 4. So C3H4. Mister, how is that possible? You can come here, okay, draw a triple bond. How many H's? How many H's does this one need? 1 H. How many H's does this one need? No H's, because I have 1, 2, 3, 4 bonds. This carbon here has 1 bond, so it needs 3 H's. So in total, H's is 1, 2, 3, and 4. Okay? So how do we give a name to this? Again, like the double bond, you name you number the chain so that the location of the triple bond is going to be the lowest. How many carbons do you have here? 1, 2, 3, and 4. So 1 butene. Okay? So it's 1 butene. All right? And yeah, that's exactly like the butene, which is the one that has the double bond. Okay? If we have a look here, you have 1, 2, 3, 4. So the location of the triple bond is going to be carbon number 2. So this will be 2 butene. Okay? Why Y and E? Because we have a triple bond here. So what's the general formula of straight chain alkynes? It's going to be this one, right? This is the formula of alkanes. This is the formula of alkenes and cycloalkanes, if you remember. And we did not cover this general formula here. طبعا this formula is only if you have one triple bond, and this formula for alkenes only if you have one double bond, only one. Okay, these are some examples of alkynes. So the triple bond is here. So sometimes they will say one propyne, or they will say only propyne. They will not write the number, but starting from 4 carbons they are going to do so. Okay, because the location of the triple bond here is always going to be 1 سواء كانت في اليسار أو في اليمين. Okay, so this one is going to be 1 butene and this is going to be 2 butene and so on. So the simplest one is ethyne. So what's the name of the alkyne with the formula C2H2? So when they said alkyne, then it's not going to be this or this. It's going to be ethyne or acetyl or acetylene, the common name. Which of the figures above is the structural formula of propyne? So when you see prop, it means 3 carbons. When you see YNE, it means triple bond. Look here, you have 3 carbons, and here you have 3 carbons, but you don't have a triple bond. So wrong. Here you have 3 carbons, you have 3 carbons, you have a triple bond, right? But this one is wrong, because the triple bond should be between carbons only. Hydrogen can make only 1 bond. Okay, that's why this is wrong. So the correct one is going to be number B. All right. What is the name of the following hydrocarbon? Now this is like, so naming alkynes is similar to naming alkenes. Okay, so you have 1, 2, 3, 4, 5, 6. Choose the longest chain with the triple bond inside of it. So this is the longest chain. Okay, now where do you start numbering? If you start from the left, 1, 2, 3, so 3 is the location of the triple bond here, or you can start 1, 2, 3, and 3 is the location of the double bond or triple bond here, sorry. So both ways is correct, both ways are correct. So you have a methyl here, a methyl here. So if you choose from up, this is going to be number 2, this is going to be number 5. Okay, so you'll say the following: 2, 5, right? Dimethyl, because I have 2 methyls, and you have 6 carbons, and the location of the triple bond is 3, so 3 hexyne. Why did we write Y and E? Because we have a triple bond here. Okay, so similar to a double bond، لكن الاختلاف الوحيد انه بدل E and E نحط Y and E. Okay, so let's say that we have something like this: CH3, CH2, CH2, 1, 2, 3, 4, 5, and then we can have also CH2, CH3, so 1, 2, 3, 4, 5, 6, 7, and then I will have here and I will have, so if I do that, then I need to make this one H, and okay, name the following hydrocarbon. Name the following hydrocarbon. Okay, so how should we do it? Okay, or how can we do it? So use your rules. You need to find the longest chain with the triple bond. So if you start 1, 2, 3, 4, 5, 6, 7. You will have 7 carbons, right? But if you think about it, you have a longer chain here. If you start from the right or from down here, for example, 1, 2, 3, 4, 5, 6, 7, 8. So actually, this chain is the longest chain that contains the triple bond. Now, how do we give numbers? Let's check. You will find that both of them are going to give the same numbering. So if I choose 1, for example, 1, 2, 3, 4, 5, 6, 7, 8, or if I say 1, 2, 3, 4, 5, 6, 7, and 8. So both of them, the locations of the triple bond is going to be 4. Now, who is going to decide which one I will choose? These methyl groups. So the location of the triple bond is 4, right? What's the location of CH3? It's either 6 or 3, right? And this CH3, it's going to be either 6 or 3. So it does not matter. Both of them give me the same combinations of number, 3 and 6, okay? So we can start with that. So 3, 6, dimethyl, right? Because I have 2 methyl groups. What's the location of the triple bond? It's 4. So 4. How many carbons do I have? 8. So octine. 3,6 dimethyl octine. Now, if they ask you to draw 2 methyl 3 ethyl 1 heptine. So the first thing that you need to do is come here, look at heptine. How many carbons are here? Hept, 7 carbons, right? So draw 7 carbons. 1, 2, 3, 4, 5, 6, 7. Now let's look. At location number 2, we have methyl. So you can choose this one or this one. It doesn't matter. So you have methyl here. At location number 3, you have ethyl. So this is ethyl. And what is the triple bond? It's in location number 1. So it's here. And now you can put the hydrogens. So there is no, for example, okay, this is connected to this one. Can we do this, guys? Is this possible? We cannot, right? Because you cannot have you cannot have 5 bonds for carbon. So instead, let's say that we will make this 5-methyl 3-ethyl 5-methyl 3-ethyl 1-heptine. So if I do this, that's going to be 1, 2, 3, 4, 5. You put CH3 here, okay? And I'm going to remove this one, okay? We'll put an H. We'll put an H here. Where's the pen? So we'll put an H here because this carbon now has 4 bonds. This carbon has 4 bonds. This carbon has 1, 2, 3. So H. This carbon has 1, so 1, 1, 2. Okay. So 1 and 2. So it needs 2 H's. This carbon has 1, 2, 3. So it needs 1 H. This carbon is connected to this one, so it needs 2 H's. This carbon is H3. Okay, so 1, 2, 3, 4, 5, 6, 7. I want you to look here and tell me if there's anything wrong in this name. Now you got it right, and I'm sure you will get this right when I wrote this, okay? So actually, you cannot have methyl before ethyl, because remember the rules. Ethyl should come first because E is before M in the alphabet. So the correct name should be 3-ethyl, okay? 5-methyl, 1-heptine. Okay, so this is the location of the methyl group. This is the location of the methyl group, and 1 is the location of the triple bond. Make sure the number of hydrogens is correct. So this carbon is connected to only 1. This is connected to nothing. This one is connected to only 1. This one is connected to 2 carbons. This one is connected to 1 carbon. This one is connected to 2 hydrogens, and this one is connected to 3. Okay, so this is correct. This is wrong. So because this one should come first. Okay. And these are some properties of alkynes. So alkynes undergo many reactions that alkene undergo. So they are like alkenes. But alkynes are more reactive than alkenes because they have a triple bond. And they have more electron density. Okay. So the electron cluster makes it more reactive. Right. So these are the general properties of alkynes. And alkynes, especially ethine or acetylene, is a byproduct from oil refining, تكرير النفط. Okay, and it can be created by reactions involving calcium carbide. Okay, and it's used in torches, especially the ones used in welding, التلحيم. Okay, so ethine is commonly used in التلحيم. Okay, it's also used in many plastics and other organic chemicals industry. Okay, so many of these compounds, because they are hydrocarbons, they are used in synthesizing plastics. All right, and you can go through these questions at the end, okay, on your own. So yeah, I think that's the end. This is the section summary. I hope you benefited from watching this video. You can stop it and watch it again later if you want, but that's the end of section 3, and I wish you all the best. Thank you very much.